So when we're solving inequalities, it's exactly the same as solving an equation. You're trying to get the variable by itself. The only difference is that you've got, instead of an equal sign, you've got an inequality symbol. And in this case, we got 3x plus 7 is greater than 13. So you've got everything exactly the same as the equations. You want to get x by itself. So you do inverse operations. So we move the 7 by subtraction. 13 minus 7 would be 6. And then the last step would be divide by 3. And that's x is greater than 2. When we write our answers, we want to be able to write them in several different ways. One of the ways is what's called set builder. Set builder notation uses the curly braces, and then whatever the variable is in your problem, you put that first, x, and then a straight up and down bar. And what that says is all the x's are these kind of answers, and after that bar is what kind of answers they are. And you put your inequality there. And if somebody were to read this and say x such that x is greater than 2, that's the solutions in set builder notation. That's what that's called. And we'll get practice as we solve some more of these, writing that. The other is interval notation. Interval notation and the number line, we'll say graph, is what we'll call that. The number line and the interval notation really go together well. So if you're looking at a number line, we're going to graph that inequality on a number line. So we're looking for x's that are greater than 2. So I'm going to put 2 in the middle, 3 and 4, and then 1 and 0. And then what I'm going to use is the notation for interval stuff. If it's just greater than 2, does it get a parenthesis or a bracket? And why? If you remember that. Does anybody remember that? Parenthesis. Bracket means you're including the number. If it had an equal to mark, we'd use a square bracket. But because it doesn't have that, we're going to use a open parenthesis. And I'm opening it to the right so that I can go greater than 2. So that the graph goes this direction. I'll just kind of shade that way, boldface that. That it goes from 2 toward positive infinity. So the interval notation is actually easier to do after you've drawn the graph. That we start at 2 and we go to positive infinity. And there's the interval notation for that inequality. Solving it and getting the inequality, that's the easy part. It's getting the answer written in the right form is what we've got to learn to do. That's really what we're after here, is getting into that interval notation and working with that. Okay, so let's do example B. Let's say we had negative 3x plus 5 is greater than or equal to negative 7. Okay. What's the first step? Subtract 5, negative 3x greater than or equal to negative 12. And then we divide by negative 3. Bless you. Okay. Anytime I divide by a negative or multiply by a negative, when I'm solving an inequality, I have to flip that symbol around so that it's less than or equal to. And then what's negative 12 divided by negative 3? Positive 4, right? The set builder notation, once you get there, just put it around it. Okay? When you multiply or divide by a negative, you need to flip that symbol around. The reason is because if you don't flip that symbol, your inequality is going in the wrong direction. The negative in a number line sense is really talking about direction instead of value. It's talking about direction. So the dividing by a negative flips the direction of the number line around. That's basically what happens. Also multiply. Anytime you multiply or divide by a negative, you got to flip your symbol always when you're solving inequalities. With equations, you can flip an equal sign either way, and it's exactly the same. So it really doesn't happen with that. But with the inequalities, you got to turn it around. So the set notation, once you get your inequality, you just build it around it. It's the easiest way to write your answer. But we got to be able to write it in other ways. So the interval notation, I think it's easier to do after you've drawn the graph. But eventually you'll get to where you don't even have to draw the graph to get the interval, just because you got a good practice at it. So I know 4 goes in the middle, 5, 6, 7, 3, 2, 1. Just get a few numbers on either side of it. And then we're going x's are less than or equal to 4. So it's got an equal to mark, so I'm going to use what? A bracket, and it's going less than 4. So am I go to the left or to the right? To the left. So the numbers that are less than 4 are 3, 2, and 1. So I'm going to put my bracket opening toward the left and then go this direction. What is the interval for that? Negative infinity to 4, and then throw the bracket on the 4. And there you've got the set notation, the interval notation, and then the graph showing that out of there. Okay. Sample C, 4 minus 3x less than or equal to 7 plus 2x. All right, we got x's on both sides, so this is similar to the equations where we had variables on both sides. We got to get the x's together. We got to get the numbers together. I'm a big fan of moving the x's to the left side, just because that's the normal way of doing things. Not the you don't have to do it that way, but it sure makes it easier to write your set notation once you get it there, right? Because once you get the x on the left side, all you got to do is move everything else. So I'm going to move 2x. And then negative 3x minus 2x, negative 5x. And then I need to move the 4. How do I move that 4? Subtract it because it's a positive 4. So that's negative 5x less than or equal to 3. And then one more step. Divide by the negative 5. And when I divide by a negative, flip the symbol, negative 3/5. Just sandwich in the set builder notation. Just throw it in there. Curly braces around it, X and a bar. Makes it easy. Okay. There's the set notation, the interval notation. X's are greater than or equal to negative 3/5. So what's the smallest answer we can get? The smallest number that can be an answer. Be negative 3/5. And they're greater than that, so we're going toward positive infinity. I'm just trying to bridge away from doing the graph first every time. If you need to, that's okay. You can do that. Negative 3/5, negative 4/5, negative 1, negative 2/5, negative 1/5, 0. Bracket going to the right. X's are greater than or equal to negative 3/5. The 3 different ways is representing that answer. Being able to move in and out of those different forms of answers is fairly important. As we progress further into 100 and 110, we do less and less with set notation and more with interval notation. So that's kind of why we want to do both here, so that you start seeing, okay, if I get an answer, it looks like this, I can get it to interval notation. Because we do more and more with the interval notation as the course moves forward.
interval notation right there, does it matter if you do parentheses or bracket on either side of that number?
It needs to be a bracket on the negative 3/5 because it has an equal to mark. It will always be a parenthesis on an infinity because you never can get to infinity. So you can't ever include it. All right, let's do sample D. Let's do a compound inequality. And that just means it's a sandwich type problem, is the way I describe them to most of my students. You got basically two problems at the same time. Okay? So you've got a negative 2 that's less than 5 plus 3x, but that is less than 20. So what you want to do is get the variable by itself in the middle. Okay? So what would you do to get x by itself in the middle? Subtract 5. And so if I subtract 5 from the middle, I have to subtract 5 from everybody else too. So I subtract it from the left side and from the right side. That's what makes that legal to do. And so that'd be negative 7 less than 3x less than 15. X is almost by itself. Divide everybody by 3. Now the one on the left doesn't go evenly, so I'm just going to leave it as the fraction, negative 7/3. Do I need to flip my symbols? No. What did I divide by? Positive 3. It doesn't matter that the 7's negative. That has nothing to do with it. It's what you divide or multiply by that makes the difference. So I divided by positive 3. I don't flip my symbols. And there's x. And then 15 divided by 3 is 5. That's already ready. You know, throw it into set builder. That's the easy part. Honestly, the compound inequalities, the interval notation is just as easy because the answers start at negative 7/3 and they end at 5. Should that be bracket or parenthesis on either end?
Bracket.
Is it bracket? What signifies using a bracket? Are there equal to marks? No. No equal to marks means parentheses. So parentheses on both of those. The graph, we know 5 is the biggest number. 6, 4, 3, 2, 1, -1, and I need to go a little further to get -2 and -3. Notice I didn't put the fraction. I forgot 0 there. In there. I just did from -3 up to +6. Where is -7/3? In between the negative 2 and -3, right? Because what's -7 divided by 3? It's -2 1/3, right? So it's about right there. And then the 5, we know where that's at. The answers are in between there. Oops. Anytime it's a compound inequality, your answers are going to look like that. If it's a sandwich type looking problem, your answers are going to look like kind of like a barbell. Is the way I look at that. Do another. 16 is less than or equal to 2x minus 4 is less than 18. The inequality symbols don't always have to be exactly the same. Notice here we got one that's an equal to mark and one that's not. They don't have to always be the same. What's our first step? Add 4. So add 4 on every section. 20. There's 2x. There's 22. Last step. Divide by 2. 10 less than x less than 11 less than or equal to x less than 11. That's pretty easy to do set with. The interval notation, it goes from 10 to 11. Which end gets the bracket? The 10, right? Because it's the one that's got the equal to mark. And the 11 gets what? Parenthesis, because it doesn't have an equal to mark. Okay. And then the graph, mimic your interval notation there. Bracket, parenthesis. I always kind of try to make those a little bolder than they originally are. And there's our solution. Solutions are any number that's between 10 and 11. Not counting 11, but counting 10. Those are the solutions to that. It really doesn't get any more complicated than that in this section. Just solving for x. Let's do one more. And then we'll the last bit of stuff here. Let's say we had 15 is less than 3x plus 9 is less than or equal to 21. What do we do first? If I subtract 9 from the middle, I got to do it everywhere else. 15 minus 9, 6. 21 minus 9, 12. One last move. Everybody gets divided by 3. 2 is less than x is less than or equal to 4. Put the curly braces and the bar in there, and you got the set notation. Interval notation. Parentheses 2, 4, bracket. Good job. Bracket on the 4 because it's got an equal to mark. Parentheses on the 2 because it doesn't have an equal to mark. Graph. 1, 2, 3, 4, 5. Parentheses, bracket, and line in between. Work that way pretty much every time. Questions about solving inequalities. When do you flip your symbol? Divide or multiply by a negative. That's the only time you flip that symbol around. You have to flip it if you divide or multiply by a negative. Okay? All right. That's correct. If divide or multiply by positive, you don't have to flip it. And you shouldn't flip it. Only time you do it is you multiply or divide by a negative. All right. Let's look at the last section that'll be on your test next week. Equations of lines. Okay? There's a few different forms that we're going to be using tonight. One of them we've already talked about before, and we're going to kind of work through all of them a little bit as we go with this stuff. So, equations of lines. The first form we're going to talk about is point slope form. Okay, point slope form looks like this: y minus y1 equals m parentheses x minus x1. All right, this m is the slope that we talked about last week. That's the same slope. The x1 and the y1, those pieces, they're an ordered pair. X comma Y. It's going to be an ordered pair that we'll be given that. So they're either going to give you the slope and an ordered pair, or they're going to give you two ordered pairs, and you've got to find the slope and use one of the ordered pairs. And we'll do examples of each of those scenarios, okay? So point slope form, this Y and this X are always, they're there. They're a Y and they're an X. The Y1 and the X1 are going to be numbers. We'll do an example in just a second. That's going to, it makes sense, okay? All right. So let's take an example, and we're going to write an equation. We'll write the equation of a line in point slope form through, here's our ordered pair, -4, comma 1, with slope of -3. Okay. All right. Putting stuff in here. Okay. Point slope form. Everything is written in blue there has got to be replaced. All right. What's the slope of this line? -3. So that's M. That X has got to be there, that first X. What's the X value in the ordered pair? -4. So that's minus -4. What's the Y value in the ordered pair? 1. So that's Y minus 1. We can simplify this just a little bit. All right, so what I've done is I've replaced the slope with -3 because they told me the slope was -3, right? This is your X1 and your Y1, okay? This is X1, this is Y1. That ordered pair is your X1 and your Y1. I'm just putting those in the place of X1 and Y1 in the point slope form, the general form, okay? So I replaced the Y1 with 1. So that's why it's Y minus 1. I replaced the X1 with -4. That's why it's X minus -4. What does minus a negative turn into? Positive. So we're going to rewrite the final answer as Y minus 1 equals -3 X plus 4. That's point slope form for that situation that they described. That's a line with a slope of -3 that goes through the point -4, +1. That's point slope form. So to do point slope form, here's the things you got to have. You got to have a slope. Got to have a point. Okay? Got to have a slope. Got to have a point. All right. Let's go to the next problem. We're going to write the equation of line in point slope form that goes through -3, +2, and 2, -4. Ew. What did they not give us? A slope. But they gave us two ordered pairs. What can I do with that? I can find the slope. Because I'm smart and I know that the slope formula is y2 minus y1 over x2 minus x1. So -4 minus 2 over 2 minus -3. That'd be -6 over 5. That's my slope. Now, here's where point slope form gets annoying for teachers. It's good for you because it gives you've got options. For teachers, it means we've got to have two answers for every problem because there's two different ordered pairs that could be used to write the equation of line. If you use -3, 2 as your ordered pair, This becomes x1 and y1. And you have y minus 2 equals negative 6 over 5, x minus negative 3. And then you simplify that to be y minus 2, negative 6 over 5, parentheses, x plus 3. That's if you use negative 3, 2 as your ordered pair. Because you got two ordered pairs. You've got to pick. Pick one. Now, on the quiz or a test, I'll tell you which one to use. That way everybody's finding the same one, and you don't have two different answers. I'll tell you which ordered pair to use on the point slope form. Okay? If you use the other ordered pair, 2, negative 4, that'd be y minus negative 4 equals negative 6 over 5, x minus 2. Simplify that just a little bit. Y plus 4, negative 6 over 5, x minus 2. That is also correct for that problem. Because you got two different ordered pairs, you could have two different answers in point slope form. Now, when we get to slope-intercept form, it doesn't matter which ordered pair you use, you'll get the same answer no matter what. Okay? But with point slope form, if I ask for it, I'm going to tell you which ordered pair to use. Because that way we don't have two different choices that could be correct. There's only one that would be correct if I tell you which ordered pair to use. Okay? Now, again, on quiz and on test, I'll tell you which one to use. But understand that you could use either or on this problem. So like labs next week, you'll be able to use either or. I'll tell you, do both of them. I'll have both answers on the labs because you need to be able to use both, honestly. Let's look at that slope-intercept form, which clears up the idea of the correct equation. Okay? Slope-intercept form, we've talked about a little bit already. F-O-R-M. Slope-intercept form, y equals mx plus b. M is our slope. B is our y-intercept. We've talked about that a little bit already. What we're going to be doing is building equations of lines in that form. And what I'm going to show you is the fact that you can go from point slope form into slope-intercept form really easily. And if you need to. The first example, we want to write the equation of a line in slope-intercept form that goes through 0, 6 with slope of negative 2. What do we know about the point 0, 6, that ordered pair? Where is it at? It's on the y-axis. It's you start at the origin, you'd go up 6 on the y-axis and put a dot. That's where 0, 6 is at. So that means 0, 6 is the y-intercept because it's on the y-axis. A line can only have one y-intercept. Can't have 2, can't have 3, can't have any more than one. Can only have one. So 0, 6 is the y-intercept. So that means that 6 is really b. It's the y-intercept. Negative 2 is m. That's the slope. So I could go straight to the equation, negative 2x plus 6. And that's in slope-intercept form. Because they gave me that ordered pair that was the y-intercept. Okay? If they give you the y-intercept and they give you the slope, slope-intercept form is super easy. Plug it in. Plug those two numbers in, you're done. They don't do that very often. This is college algebra, or the essentials of college algebra. So let's look at what they really give us most of the time. They're going to give us another ordered pair. And they're going to say it's going through negative 4, positive 1 with slope negative 3. That's not as nice if I'm trying to write it in slope-intercept form. But they gave me a slope and a point, What form uses a slope and a point? Point slope form, what we just talked about. I could write the equation in point slope form and then work from there to get slope intercept form. That's the key here, is being able to take from one form to another form. That's what we're working toward. Okay, so I'm going to try to start with point slope form because I have a point and I have a slope. Those are the two things I need for point slope form. And that would be y minus y1 and m x minus x1. Again, this is m, this is x1, this is y1. That's what those things are. We're just going to plug them in the place of those pieces. And then simplify it a little bit. I mean, -3, and then that's x plus 4. Now, that's not slope-intercept form, right? That's point-slope form. What does slope-intercept form look like? What's by itself? Can I get y by itself with this problem? Couple of steps and I got it, right? Because on the right-hand side, I could distribute -3 to both of those pieces and get -3x minus 12. And then I'm one step away from having y by itself. What's that step? Plus 1 to the like term. -3x minus 11. Now, I'm going to show you on the graphing calculator that actually works. So I'm going to type in -3x minus 11. And I'm going to graph that. So that's the graph of that line. What was the ordered pair they gave me? -4, 1. So I'm going to hit trace, and I'm going to type in -4. And I want you to look at the ordered pair that comes up on the bottom. -4, 1. That means that line went through that point. It wouldn't happen by coincidence. There's nothing coincidental in my opinion, in life, especially not in math class. So there we have -4, positive 1. The ordered pair they gave me. It's not a coincidence. Now the y-intercept, it's down here. It's like -11. It's just off the screen. We know that that's where it would be at. Doesn't necessarily always match up with that ordered pair unless the ordered pair is 0, something. Okay? So we're going to build through point slope form into slope intercept form. That's what we're trying to develop here. Let's do another problem. Same idea. Letter on E. Let's say it goes through 6, -8 with slope 2/3. Throw a fraction in there. Okay. What information did they give me? A slope and a point. That tells you point slope forms where you want to start. They didn't give me the y-intercept, right? The only way that I know the y-intercept straight off the bat is if the x value in the point is what? 0. Okay. If that ordered pair doesn't have a 0 in the x position, that means you got to start at point slope form. Okay. So I'm going to start with point slope form. Y minus -8 equals the slope, parentheses, x minus 6. And then I'm going to work toward getting y by itself. Two-thirds x minus, what's 2/3 of 6? 4. And then get y by itself. One more step, -8. Thirds x minus 12. And there's our slope-intercept form from that. If you can get point slope form down, the other slope intercept form is only 2 steps away in math steps. It's just 2 steps away. That would make a great song title. Just 2 steps away. Let's go for slope intercept form through -3, 2 and 2, -4. So if we're going for slope-intercept form, are either of those points the y-intercept? No, because neither of them have a 0 in the x position. So we can't take a shortcut. We've got to go through what things do we need to write the equation of the line here. We got to have a slope first. So let's find that slope. -4 minus 2, 2 minus -3. -6 over 5. -6/5 is our slope. Now, here's where you again get the choice about what ordered pair you're using. We're going for slope-intercept form. So it doesn't matter which ordered pair you choose. I'm going to show you both of them here because we did this. Actually, this is the same problem as example C was. When we work that, y minus 2 equals -6/5 x plus 3. That was the slope. That was the point slope form when you're using the point -3, 2. If I work that and get y by itself, it's got a fraction in it. Yeah, that's ugly, but it's okay. It's just part of life. -6 over 5x minus 18 over 5. And that's just distributing -6/5 to both pieces there. And then I'm going to add 2. -6 over 5x. And then that'd be 10 over 5. Be -8 over 5. Right? Is that right? Without using the calculator. That's the slope-intercept form of that. That's if I use the point -3, 2. If I go over here and I use the point 2, -4, my point slope form looks different. Definitely this one is different than that one, right? Let's get y by itself on this one and see what happens with our slope-intercept form. That'd be -6 over 5x plus 12 over 5. That's y plus 4. And then I'm going to subtract 4. So that's -20 over 5, and 12 over 5 is -8 over 5. If you don't trust me. 12 over 5 minus 4. Math, enter. -8 over 5. Notice what's going on with our slope-intercept forms. They're exactly the same. No matter which ordered pair I chose for point slope form, the slope-intercept form works to be the same. That will always be the case. And it doesn't matter which ordered pair. If you did point slope form correctly, your slope-intercept form will be the same as if somebody used a different ordered pair. Okay, so it doesn't matter which one you choose. You pick the one you think's the easiest. It doesn't really matter on this one. They're about the same. Okay. All right, let's do one more like that, and then we'll go on to standard form. Let's say we had it through 6, 8, and 5. 10. That's a good one. We want to write the equation of that line that goes through those 2 points in slope-intercept form. What's the first thing I have to find? Slope. Okay. If I'm going to write the equation of a line, I got to have a slope, and then we go from there. So the first thing I find is a slope. How do I find the slope? Yeah, y2 minus y1, so 10 minus 8 over 5 minus 6, which is 2 over -1, which is -2, right? Pretty good slope. It's not a fraction, nasty looking fraction, so that's nice to use. Now, does it matter which ordered pair I use for point slope form? No. Pick the one you think's the easiest. I don't know, 5 and 10 looks pretty easy. I'm pretty good at my 5s and my 10s multiplication table, so I'm going to stick with that one. So, what's my point slope form? -2 x minus 5. Either that, or if you use the other ordered pair, it'd be y minus 8, -2 x minus 6. Either of those for point slope form is correct. They both will end up with the exact same slope-intercept form if you do it correctly. Okay? Got to do it correctly, but they will end up with the same slope-intercept form equation. So, from there, let's work this one over here. What do I do with that? Distribute. So that's -2x. -2 times -5 be positive 10. Add 10 to both sides. So that's y equals -2x plus 20. The y-intercept is 20. The slope's -2. If I did the other problem, we can easily see that we get the exact same solution. That they're the same equation, no matter which ordered pair I use. You've just got to do one. I'm showing both of them here for notes purposes. You just do one of them. No sense in doing both of them. They're going to be the same. Now, if you're unsure of yourself, you want to try the other one just to make sure you did it right, yeah, go for it. That's true. They should work. Okay. So that gets us from point slope form into slope-intercept form. And then we need to be able to work into what's called standard form. It's the last form that we need to talk about tonight. Okay. All right. Standard form. Standard form puts x and y on the same side. They use ax plus by equals c. A, B, and C are not fractions. That's the rule. You've got to, if there are any fractions involved, you got to get rid of them. Okay, that's the rules for standard form. No fractions can be in the problem. So no fractions in standard form. Slope-intercept form, fractions are cool. They're okay. Point slope form, fractions are cool. They're okay. Standard form, no fractions can be there. We'll look at how to get rid of them in just a little bit, okay? Now, the key with standard form is the fact that if you can get slope-intercept form, standard form is one step away. All right? So, with point slope form, we start there, then we get to slope-intercept form, and then from slope-intercept form, we're one step away from standard form. So we're going to get through all of the forms to get there. All right. So let's first look at a problem that's in slope-intercept form. Put y equals -3x minus 11 into standard form. So that equation, y equals -3x minus 11, that is in slope-intercept form, correct? How do I get it in standard form? Remember, standard form gets x and y on the same side. So if I want x and y on the same side, y's over here. This side has got x and another number. I need to get rid of this guy, right? How do I move him over there? Add it to the other side, right? So if I add 3x, I meant to do those different color. That'd be 3x plus y equals negative 11. What do you know? Standard form. And you're done. If you can get slope-intercept form, standard form is that easy. But you got to be able to get slope-intercept form. So we're going to get some practice. We're going to look at it, see what's going on. It's the C. It's the C in that it's not necessarily a y-intercept or an x-intercept. It's none of those things. The standard form is kind of weird because you don't get really anything out of it. You don't get a slope. You don't get an x-intercept. You don't get a y-intercept. You just got this, this equation that has x and y on the same side. It is graphable. If I were going to ask to graph an equation that was in standard form, I'd go to slope-intercept form and do it. Because it's going to be the same line no matter what. Okay, good question. All right, so let's look at one more of those, and then we'll build an equation. We'll actually write the equation from some information. Let's say we had we want to put y equals negative 6 over 5x minus 3 into standard form. Okay. If we want to put that into standard form, what move do I need to make? Move the x stuff. It's a negative 6 over 5x. So to move it, I need to add it to the other side. And I have 6 over 5x plus y equals negative 3. That's almost standard form. What's the one rule about standard form? No fractions. Okay, so what can I do to get rid of the 6 over 5 as a fraction? What can I do to get rid of that denominator? What does a fraction even mean? Yeah, I can multiply by 5. It's dividing, right? 6 divided by 5 is what 6/5 means. So if I multiply by 5, it'll get rid of that fraction. But I can't just multiply the x part by 5. I've got to multiply everybody by 5. So I multiply each piece by 5. The whole problem gets multiplied by 5. And I'm showing each individual piece getting multiplied by 5. 6 over 5 times 5. The 5's cancel out. And it's just 6x. 5 times y is 5y. 3 times, or negative 3 times 5. Standard form. Okay. We'll do one more of these before we move on to actually doing the whole shooting match. Let's put y equals 3/4 x minus 1/7 in standard form. This is the hardest ones to get in standard form. We'll put that in standard form. What would be our first step? Move the 3/4 by subtraction. I'm combining both y'all's answers there. So that's negative 3/4 x plus y is equal to negative 1/7. Ooh, 2 fractions in the problem. That's not so nice when there's 2 fractions. They got different denominators. When I'm thinking about fractions and different denominators, that should make me think about what kind of denominator. When you're dealing with fractions, what kind of denominators do you try to usually work with? Starts with a C. Common denominators. What would the common denominator between 3/4 and 1/7 be? 28. Why? Absolutely. 7 times 4 is 28. 4 and 7 both go into 28 evenly. So if I multiply this whole problem by that common denominator, 28. So I'm multiplying this whole thing by 28. Each individual piece. Well, 28 times negative 3/4. And then that'd be 28y. And then I've got 28 times negative 1/7. So I'm showing an extra step here just to show what's happening there. I would probably do that with a calculator, no question. I know, I probably wouldn't, but most of us would. I would say negative 3/4 times 28. I know that's negative 21. And then I know that's 28y. And then 1/7 of 28 would be 4, right? So that's negative 4. Then I'm in standard form. Now, if you don't understand why we're using 28, you can do it in 2 separate steps. Multiply it first by 4 across everybody. Then once you get that answer, multiply that answer by 7. Do it as 2 separate steps. That works too. 28 gets it in one swoop instead of 2. Okay. So if you want to use 2 separate multiplications, you can, and it gets you the same answer. Or you can use that common denominator idea and just do it in 1. And that'll get you the standard form there. Okay? Now, let's write an equation of a line in all 3 forms. I don't know what letter I'm on here. K, J, K, and Z. We might get there before we're done. All right, so no, we won't be that long. We're going through 1, 1 and 2, 4 in all 3 forms. Okay. If I'm going to write this equation of a line, what do I need first? I got to have a slope. So let's get the slope. Four minus 1, 2 minus 1. It's 3 over 1, right? Slope's 3. Now, I've got the slope. I've got 2 points that I can use. It doesn't matter which one I pick. Which one's the easiest one? 1, 1. Why is it the easiest one? Because they're both the same. You can't screw it up, right? If the numbers are the same, you can't put the X in the wrong spot and the Y in the wrong spot. Okay, so when I do my point slope form, that's the one I'm going to choose. I'm going to say Y minus 1 equals 3 X minus 1. And that's point slope form. I don't have to do any simplifying to it or anything. I'm done. And then I want to take that and put it in slope-intercept form. How do I do that? What's the first step? Distribute. That's the right first step. 3 times x and 3 times 1. So that's y minus 1 equals 3x minus 3. And then one more step. Add 1. So that's y equals 3x minus 2. There's our slope-intercept form. Now I want standard form. Then all I got to do is subtract 3x. I'm going to rewrite it and show that step. So I'm going to subtract 3x. And there I have negative 3x plus y equals negative 2. And Paul, to kind of go to what we were talking about earlier about equivalent answers, that answer and this answer are the same. Why? Paul and I were having a conversation about one of the problems from last week's material, that you could get the same, you get 2 different answers that are equivalent, but they don't look the same because of the signs and all that stuff. So on this one, what's different about the top one and the bottom? All the signs have changed. So that they're equivalent solutions, but the signs are different.
Maybe they're going to start in a different position, but have the same slope and everything else.
Everything is the same about them. Yeah, but it would be like starting in a different place. But the line is exactly the same line. And so just know that if you change all of the signs, then it's still the same answer. You can't just change part of them. You got to change all of them. Okay. All right. Couple more things, and we're out of here. Okay. Last couple of things is taking this same idea. We're still going to practice writing equations of lines, but we're going to be dealing with parallel and perpendicular lines. What do we know about parallel lines? Never touch. Mathematical word for that is never intersect. Never touch. Two lines are parallel. They will never intersect. Never touch. What else do we know about them? Equal distance between them. Okay. Part of that idea, when they're never intersecting and they're equal distant between them, is the reason that is consistent is because they have the same slope. And that's the key piece of information that we're going to be using in writing equations, is the fact that parallel lines do have the same slope. So if two lines are parallel, the slopes of those two equations will be exactly the same. And that's going to allow us to just kind of borrow the slope from one equation and use it for another one. That's what we're going to be doing. Okay, so L, are we on L? All right. So let's say we want to write the equation of a line that goes through the point 3,5 parallel to 2x plus 5y equals 4. All right. So with this type of problem, it's just like the other ones, except for they're giving us the slope in a disguised kind of way. They're being a little sneaky about, okay, what slope are you going to use? Parallel, the word parallel in there tells us, oh, it's going to have the same slope as this equation. But what's the slope of this equation? Say it again, Paul. No, not quite. It's close. Closer than some of the others. Oh. Got to get what by itself so we can get the slope. Got to get y by itself. Get it in slope-intercept form so you can pull the slope off of it. So I'm going to subtract 2x. That'd be 5y equals negative 2x plus 4. And then I would divide by 5. The only part of that equation that I need is that part right there, the slope. The y-intercept doesn't matter. None of the other part matters. We just need the slope. The parallel line has the same slope as that. So if I'm going to write the equation of a line that's parallel, then this is the slope I'm going to use. Okay, so you got to pull your slope from the other equation, and we're going to use that one. So let's start with point slope form. Y minus 5 equals negative 2/5 x minus 3. There's point slope. All I did was I took the ordered pair they gave me, and I took the slope from the equation they said it was parallel to. Nothing fancy about that at all. It's just taking it and throwing it into the point slope form. Now let's put that in slope-intercept form. That'd be y minus 5 equals negative 2/5 x plus 6/5. That's just distributive property with the negative 2/5. And then I need to get y by itself. Negative 2/5 x. That'd be 25/5. Be 31/5. Check me with the calculator, somebody. Just make sure I'm right. It is good. So there's my slope-intercept form. There's my point-slope form. We're one more form away from having them all. So let's go ahead and do the standard form. How do you get that in standard form? Add 2/5 x, yeah. That's 2/5 x plus y equals 31/5. How do I get rid of the fractions? By everybody gets multiplied by 5. 2x plus 5y equals 31. And there's standard form. Parallel lines have the same slope. Everything else about the work is the same, just where you get your slope somewhere different. It's from an equation. Parallel lines have the same slope. Gotta have that locked in. All right. Now, last thing. Perpendicular lines. What do we know about perpendicular lines? They do cross. They do intersect at 90-degree angles. That's what makes them perpendicular. And that's what makes this whole thing work, is the fact that they're intersecting at 90-degree angles. The slopes are opposite reciprocals. Let me slide that out a little bit there so we'll rewrite it. Opposite reciprocal. What that means, you flip and change the sign. Flip and change. Flip and change. Okay? Now, whether we're on M. Yeah. Under M. All right. We want it through the point 3,5 perpendicular to y equals negative 2/5 x plus 8/5. Now, that is this in slope-intercept form? So the slope that we're going to be building from is what? 8/5 or negative 2/5? Negative 2/5. That part is the only part I'm concerned about in that equation. Since it's perpendicular, what am I going to do with that slope? 5/2, change it to, and make it positive. Flip it over and change the sign to make it perpendicular. So what I usually do is I'll write over here on the side, I'll write perpendicular slope. And I'll write, oh, it's 5/2. That way I've got somewhere where I've written down my perpendicular slope is 5/2. Flip the slope and change the sign. Flip and change. Flip and change for perpendicular. Parallel stays the same. Perpendicular, flip it and change the sign. Then the work's exactly the same after that. You go start with point slope form. Y minus 5 is 5/2, x minus 3. Done. Then go to slope intercept. Be y minus 5, 5/2 x minus 15/2. Just move the 5 addition. 5 over 2x. And then that'd be 10 over 2, be negative 5 over 2. And then take that and go to standard. I would subtract 5 over 2. And how do I get rid of the fractions? Everybody gets multiplied by 2. That's negative 5x plus 2y equals negative 5. Or I could also have 5x minus 2y equals positive 5. Either of those would work for standard form. They're the same because all the signs changed. Nothing gets any tougher than the perpendicular ones. You've got to remember to flip it and change the sign. So if it started with a positive slope, when you flip it, your perpendicular slope is going to be negative. Keep that in mind as you're doing those, and just all the work start with point slope form, work your way through to whatever form they need. If they ask for point slope form, you're done. If they ask for slope intercept form, you're 2 steps away. If you ask for standard form, start with point slope, go to slope intercept, then the standard. That's the easiest way for me to give you a process to get through all of that stuff. Okay. All right. That is the week. On page 226, that's this section. 1 through 51, some good practice for that stuff. That's 2.5. 1.7, did I write any of that down? Page 145, 1 through 37, some good practice with that. Keep in mind, next week we've got our exam over what we covered last week and what we covered this week. We'll do labs beforehand. That'll give you a chance to ask questions, all that stuff. Feel free to email me anytime this week, getting some help. Canvas quiz is out there for you for this week. It doesn't have. I think it's only got like 33 questions on it, so it's a little shorter than some of the others. So you guys have a great week. Enjoy the nice fallish weather we're having.